I want to set a scenario up for us right now. And that scenario is going to allow us to expand our knowledge. Right now, we know how to figure out the number of subnets. We know how to figure out the number of hosts. We know how to borrow bits. We know how to figure out the new subnet mask. So that's nice. It's nice. But in reality, you still don't know where the start of every subnet is, where the end of every subnet is, and what are the usable addresses within that subnet. And that's truly what you need to grasp. So we're going to set ourselves up with a large example here, a large scenario, and then we're going to build upon that. So first and foremost, let's go ahead and take our private IP address space of 172.16.00/16, and I want to set it up so that way there we have 100 subnets. And as a result of that, I want to answer the various questions. How many bits need to be borrowed? What's the new subnet mask? How many subnets are created? And how many hosts can be in each of these subnets? So let's go to a whiteboard and let's get started with that. So we know that we're starting off with a /16. We know that we have we need 100 subnets. So what's the equation we're going to use here first? We're going to say 2 to the power of s is greater than or equal to 100. Now, why am I using greater than or equal to? Because I know nothing to the power of 2 equals 100. Or 2 to the power of something does not equal 100, right? No, because we know our powers of 2 are going to be 2, 4, 8, 16, 32, 64, 128, 256. There is no 100 in there. So definitely, what I want to figure out right now is how many bits need to be borrowed to be greater than or equal to 100, as close as possible to 100. Well, that's going to be 7. So S in this case is going to equal 7 because 2 to the power of 7 is going to give me, 2 to the power of 7 is going to give me 128 subnets. So right now, I know I need to borrow how many bits? I know I need to borrow 7 total bits. 7 total bits. And that's going to give me 128 subnets. So we already know that we're going to get 128 subnets and we're going to borrow 7 bits. So what was the other question? The other question is, what's the new subnet mask? Well, the new subnet mask is going to be based on our original subnet mask, which is a /16. So we have a /16, and we're going to add to that the number of bits that we're borrowing. So 16 plus 7. 16 plus 7. What does that equal? It equals 23. So our new subnet mask is going to be a /23. And then how many hosts are we going to have in each one of these 128 subnets? Well, you take your 32 bits, which is the longest subnet mask you can have, and you subtract from that your new network bits. So we have 32 as the longest possible value of a subnet mask. Subtract from that 23, and what do you have left over? Excellent. 9. So 9. 9 what? 9 host bits. 9 host bits. So what's our equation now for hosts? 2 to the power of h minus 2 is going to have to be equaling the number of hosts that we can have for each and every single subnet that we've created. So 2 to the power of h is 9 in this case. So h is our 9 that we see over here, the number of host bits left over. So 2 to the power of 9 is 512, minus 2 is 510. All right, so if we go back to our scenario that we had and we answer our questions, how many bits need to be borrowed? We said 7 total bits. What's the new subnet mask? /23. How many subnets were created? We said 128 in total, so we have 28 spares because we only need 100 according to this scenario. And how many hosts can be in each subnet created? It was 510 hosts in each of those subnets. So now we're set up for the rest of our scenario that we want to go through.